we go to start up the boiler, we have a couple important points that we need to get ready. The main one is obviously feed water to make the steam, and we need to have our fuel train set up. So we'll start here on the feed water side. We'll take a look at where everything comes from. So on the other side of the plant, we have a couple of feed water pumps. We've got one of them running already. The boiler's already running, but where it'll come through is we've got a main header up here that comes down through this green pipe right here. This is where all the water for boiler 2 is going to come in, right down here. Obviously, those valves are open. Now you can probably see here as well, we've got our feed water control valve right here. That's going to be controlled from our HMI, or human machine interface. And of course, we want to make sure the inlet and outlet valves are open for that. But you'll notice on the back as well, we've got another valve there. That's for the bypass. So of course, if the control valve were to fail, we can also manually override and get water into the boiler as needed while that is being repaired. Now, as we come over here, you see on the back end, past the bypass and the control valve, we come over here and we come up into this line. This line here is going to get us right into the economizer. And then the second line at the top, feed water is going to come back down again at, of course, a higher temperature. And then because we just like to add pipes everywhere, it'll come over here and up to go into the boiler again. So this valve here is going to be this is our main isolation for the boiler. So when we shut down and we don't need water going to the boiler, we just close this one off. That cuts any access to the boiler. Now, if while we're running, for whatever reason, we needed to bypass the economizer in whatever situation that may be, we do also have a bypass right here. So we can circumvent this whole line here, just get straight into the boiler. Of course, only do that in certain circumstances. So. And then here this is an important part as well. These lines are hooked up to be able to take water samples. So we've got steam and drum water samples. We can just take the samples out of there. That one's closed off. Let's see here, that one there. So we can just get drum samples just like that for all of our water testing. Perfect. All right, let's take a look back here. So this is another important component for the boiler. Attached to the mud drum here, we've got the blow-off valve. So we've got two types of blow-off that can happen in a boiler. We've got intermittent blowdown and continuous blowdown. Our continuous blowdown is a bunch of components up here. Constantly blows down the water to maintain our dissolved solid levels. But if for some reason it gets too high, or we get excessively high drum levels, we need to just get that level back down. These valves are what we are going to use to intermittently blow down the boiler level so we can get rid of some of that sediment or whatever it is that we may need to get out of the boiler. So, yeah. We also have chemical injection line right there. That's another important one. So the other important part of any boiler is, of course, having a fuel train. So this line comes from the main line for SATE, or for the building, I should say, comes in, and this is our boiler isolation valve right here. So of course we're running, we've got this set on. Following the train along, we've got our regulator. And just a little bit further right here, this is our low pressure sensor. So if the fuel pressure gets too low, that of course could be dangerous for the operation of the boiler. It'll detect the low level, it'll send the transmit signal to the HMI, and then that'll cause the whole boiler to shut down, shutting out all of our valves as well. The other part that happens right here is we've got a split where we end up with the main burner line and the pilot lines. So pilot lines, we've actually got two of them on this boiler. We've got one of them that goes a center fire, another one that actually fires right into the ring of the burner. And what this does is having it go into the ring actually helps with the mixing for the combustion. You get better fuel air mixture basically. And then on the bottom, we've got the vent. Got the valves for the main burner. And you'll notice we've actually got 3 of them. We've got these 2 right here, which of course stay open while we're operating. This 3rd one right here, which is attached in the middle, this is our vent valve. So in the event that we have an emergency shutdown or just whenever the boiler is off, these 2 valves are going to close and then this valve is going to open. The reason we do that is because when the boiler is off, we do not want any natural gas flowing into the furnace. So if either of these valves were to start passing for whatever reason, they're wearing out, this line being open allows the natural gas to vent to the atmosphere so that we're not creating a bomb inside the furnace. It can just safely vent to the atmosphere where nothing's going to happen. Following along here, one of the other important valves, I don't remember the name off the top of my head, but these guys here are direct, as you can see, are connected directly to the HMI. And the reason these are so important is because whatever position the valve is in, this part here is going to actually send that information to the HMI. And if all of these are not open at startup, it's going to actually prevent the burner management system from powering on the boiler because it recognizes this part is cut off. There's no way we can get gas. We can't start up right now. So another little safety feature that's integrated into the burner management system. Then another important one here we've got our instrument air. So running right about 50% right now. This line right here is what's connected to our flame scanner, fire eye, whatever you want to call it. Connects right up here. One of the important things about instrument air, especially when it comes to sight glasses or having our fire eye, is that it keeps, not only does it keep the sensors cool, but it also makes sure that these sensors stay clear, because in any furnace, of course, you're going to have sediment that can build up. And if you don't have air blowing on it to keep it clear, it could start to get plugged up and not be able to actually do what it's supposed to do and detect if there's flame burning. Yeah. Where the economizer is set up here. So the feed water coming in from the feed water pumps is only at 107 degrees, which is perfectly fine. But going into the economizer, when it comes out, you'll see that it's already up to 120 degrees. So that's going to also save us a little bit of fuel consumption, going to make the boiler more efficient ultimately. So the 204 degree flue gases are coming into the economizer, bringing that feed water up about 12 degrees, and then venting to the atmosphere at 121 degrees. And that's boiler 2 operation for you. So this is one of the feed water pumps we have to, of course, feed water to the 2 or 3 boilers we have here in the Synovus building. This is a multi-stage centrifugal pump. It is 10 stages, so you can see the actual 10 rings along here where the water is going to be pumped through by the electric motor. Of course, one of the important parts of operating any pump is that you're making sure it's primed. You don't want any water or anything here going to cause cavitation, basically destroy your pump at that point. So we've got our quick acting valve here. You just open this guy up, and we can actually see in the vent over here that there's water flowing. And because there's no air bubbles and no sputtering, we know that it is primed. So this is going to be our suction valve or suction inlet here. Of course, this valve you always want to keep open. Again, otherwise you're going to cause the pump to cavitate, destroy all of the internal components. And this is going to be our discharge line. This part we can actually close if we need to, because while this will go to the boiler, we have an automatic recirculating line here. That's just going to go back to the deaerator if for any excess water. So you're not going to destroy the pump that way if this valve is closed for whatever reason. In fact, it's generally recommended, depending who you talk to, that this valve stays closed when you start up the turbine, just to make it easier for it to get running.
So all your water for that pump is coming from the deaerator?
Yeah, that's right. All of it's going to come from the deaerator. So it's already been treated. It's already had calcium and magnesium removed from it with the softeners in the back. It's had most of the dissolved gases removed from it in the deaerator. Anything else that's left in there, we can actually deal with the chemical injection pump into the boiler if there's anything excess in there. Yeah. Of course, we've got our pressure relief valve here. So if the pressure gets too much inside of here, and we don't of course don't want to overload the components, so This guy will pop and it'll allow the water to just flow into these pipes here and release into the discharge tanks.
That's a relief valve?
Pressure, yes, pressure relief, yeah. So, yeah. Less on the pipe fitting side, more the electrical. Of course, we have the electrical box. Circuit needs to be closed, otherwise the electric motor won't run. You're not getting any pressure out of that. So, right over here, just behind us, we have the control boxes for all three of our pumps here. So you can actually program them to have local control, where I can control the speed of it right here using these little arrows, or we can set it to remote, which is what we always do here in the lab. So on remote control, we can then go back to the human machine interface and control everything we need with the pumps from there. So it's nice and efficient to have everything all in one place as opposed to running back and forth. On the note of the suction valves, this valve right here is important to always be open. Between the deaerator and our pumps downstairs, this valve, obviously, if it's open or closed, will determine if any water continues to flow down to the pump. So whenever you're starting up the feed water pumps, you got to make sure this valve is open. It's likely going to be open, but if it's not, you're destroying your pumps because there's no flow between the deaerator and the pumps. So, important point, save yourself some money. So this is the deaerator that we generally work with here. Both of them do exactly the same thing, but we just happen to run this one most of the time. So up top, we've got our pressure and temperature, local temperature and pressure gauges. And you'll see as well that we've got the little blue transmitter there. That's going to be our pressure transmitter, which will go to the HMI. Down here, we've got our chemical injection feed. We've got our water testing line so that we have automatic testing that goes on, flows out, and lets us know if there's any major issues going on inside the deaerator. An important part here is that if for some reason our graver softeners were not working properly, getting our tests here, we'd be able to see if anything substantially increased without our knowledge or underneath our noses. So that's really important to make sure that the whole operation upstream from here is still working properly so that the deaerator isn't having to do extra work heating up extra minerals inside the water. As with any vessel that has water or has heat and pressure, we have a relief valve here. So obviously right now it's closed, we have normal operations, but if the water level goes above 1300 millimeters, this valve is going to automatically open, and then it'll drain down until it gets to our set point of 1200 millimeters. Vice versa, if the level gets too low, we have another trip, which I don't remember exactly where it is right now. But basically what will happen is if we go below 1100 millimeters, then we're automatically going to get feed water coming in from the softeners to make up for it, to make sure the level doesn't get too low. And keep the operation of the deaerator as it should be. So because this is the last step between the feed water coming in, being treated, and going to the pumps to go to the boiler, we don't want the water to be cold, right? Like the city water coming in at the softeners, that's just going to be whatever the city water temperature is, goes through the softener, it does its job. But once we get to the deaerator here, we want to start warming it up so that it saves us having to do more work down the road, so the boiler's not getting 20-degree water screwing up its operation of trying to boil it at 130, 140, whatever degrees it's at. So we've got a steam line that comes in here. This is actually fed from the state power plant, so it doesn't come from our boilers here, but we get a constant feed of steam into the deaerator that makes sure that the deaerator deaerator temperature maintains at a constant approximate 108 degrees Celsius. And of course that helps to keep the pressure so that we're not boiling inside of the deaerator. This valve here is what controls it. And if you actually look right underneath here, we've got our control panel, or not control panel, but we have our display here. We've also got a physical display underneath that shows approximately how far open the valve is. And right now we're actually running at about 42%. So it's making up for a little bit of feed water coming in right now. And right behind you here, we've got an HMI where you can see the whole operation of the deaerator. So this program, for some reason, decided that red means running and operating. So we've got one pump running, pump A at 80%. That's what's feeding boiler 2 right now. And you can see right there, 109 degrees, 1102 millimeters. It says M, but it's, 1102 millimeter tank level. You can also see how much water we've got coming in, the soft water, low pressure steam for heating. Then you can also see the outlet pressures there of the pumps. And we're getting about 2,100 kilograms an hour fed to the boilers.